Hello, in this video, we are going to be taking a look at parts per million calculations. Like all of our other calculations, this is on the back of our reference table, so we do not need to memorize our formula. It is given on the back of our reference table. So parts per million is actually a lot like the percent composition calculation that we did in the previous one. We are doing grams of solute over grams of solution, so that would be similar to mass of part over mass of whole. And instead of multiplying by 100 like we did in the percent composition calculation, since it's parts per million, we are multiplying by a million. We also have a calculation called parts per billion, and in that one, we would be multiplying by billion. Now, just as a reminder, a million in scientific notation is 10 to the 6. So often, instead of writing out the one with the 6 zeros, I will just write 10 to the 6 because it saves me some space. All right, so in our first example here, we have 0.01 grams of NaCl is dissolved in 750 grams of solution. So we are looking for the concentration in parts per million. So we do the grams of our solute, which is the grams of what is getting dissolved, over the total mass of the solution, which would be 750 here. And then we multiply by a million, so you can write that out as the one with 6 zeros. Or like I said, just plug in 10 to the 6, whichever one you think is easier. We put that into our calculator. And that gives us 13.3 parts per million. So to elaborate a little bit on what parts per million means is if we had a million parts, like a million little molecules, 13 of them would be the NaCl. And we'll be looking at an example of this in class where I have a jar of a million beads and there's various concentrations in there. Parts per million is used very frequently with environmental work, where even a small amount of a contaminant is a big deal. So you typically with parts per million have a pretty small amount of your solute. This next example, we have a slightly bigger amount. We have the 12.5 grams of copper sulfate, and our water is 550 grams. So our whole sample is going to be 551.25 grams because the mass of our part or the grams of our solute, and then the whole thing. So if we think about the whole solution, if you're adding the two things together, you are going to get 551.25. So that's a little confusing because sometimes we add them together, sometimes we don't. So that comes from careful reading. So if it says that the sample has a mass of 550 or the whole solution has a mass of 550, then you wouldn't be adding them together. When they give you the individual parts, that's typically when you add them together. So that just takes careful reading of the question. All right, so we plug 1.25 divided by 551.25 times a million into our calculator, and that gives us 2,267.6 parts per million. Units, just parts per million, the grams cancel out. We would want three significant figures, so 2,270 parts per million for our answer. All right, last question. We are looking for how much iron would be in a 5,000 gram solution if the iron concentration was 500 parts per million. So this time we are given the concentration of 500 parts per million. We are looking for the grams of iron. Our whole solution has a mass of 5,000 grams, and don't forget about the million over there. So you could cross multiply first, or we could divide both sides by 1,000. So if we cross, or sorry, by a million. So if we divide both sides by a million, we would get 500 divided by a million, and that would give us a 5 times 10 to the negative fourth, or of course you could write that in number format, 0.0005 is equal to x over 5,000. So then we would cross multiply and take the 5 times 10 to the negative fourth times 5,000, and that would give us a value of 2.5 grams for our answer. We would want three significant figures, so 2.50. So if our solution had a concentration of 500 parts per million, and if our solution is 5,000 grams, that would contain 2.5 grams of iron.